Alright, so lesson 2 goes in Bruce, section 8.7 up to 8.11. And the lesson only has two objectives in it. The first objective is to apply the aromaticity criteria. So we're introduced to a term called aromaticity, actually probably in the beginning of chapter 8. And then the question is, what is aromatic and what is not aromatic? So Bruce describes aromaticity in, she talks about two criteria. Section 8.8 is the two criteria for aromaticity. 8.7 introduces it. 8.8 says that there are two criteria for aromaticity, but the two criteria can really be broken down into four. Okay? And so the four are this: that any aromatic compound must be cyclic, it must be planar, which is a little bit more difficult to see on paper sometimes. The conjugation must be complete, and it must have a Huckel number of pi electrons. Okay? Where a Huckel number is 2, 6, 10, 14, and so on. Right? Obviously, 2, 6, and 10, the lower numbers, are the ones that we're going to be most interested in because they're the structures that we can see and make real easily. Okay, so I mean the first example, of course, is benzene. That's section 8.7 talks about benzene being an aromatic compound. Section 8.7. And let's note here that first of all it's cyclic. Check. It's planar. It's hard to tell it's planar. It is planar, but that's going to be something that we're going to have to, it's going to be a little more subtle, I think. It's complete conjugation. That means that this is, these two are conjugated, these two are conjugated, these two are conjugated, right? So the conjugation is complete. And another way that I sometimes say that in a class, it has an uninterrupted cycle of unhybridized p orbitals. Okay? That's really number 3. Uninterrupted cycle of unhybridized p orbitals. In other words, this is sp2 hybridized, 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 and this is sp2 hybridized. Okay? Pardon me, I'm blotching here with this black ink. And that means that the remaining atomic orbital of this atom is an unhybridized p orbital, right? One of the s's is here and two of the p's are here. There's a remaining unhybridized p orbital. There's a good picture for this on page 348. On the Bruce text, page 348. You may want to go and look at that. The unhybridized p orbitals. Okay, number 3 is a bit complicated, but it's going to be easy to see later. And the Huckel number is perhaps the easiest. The Huckel number of pi electrons. So these are pi electrons, these are pi electrons, and these are pi electrons 2, 4, 6. And that's in the Huckel number right here. 2, 4, that's a 6. And so yes, this is aromatic. Alright, so again, the objective number 1 is to apply aromaticity criteria to a bunch of things. Okay? And so we've just done that with benzene. Let's do that now also with, say, pyrrole. Pyrrole, it looks like this, and I just looked that up. It's not something you're supposed to know. Okay? And it's got a hydrogen on it too. Okay? So, is this cyclic? Yes, absolutely. 1, 2, 3, 4. Yes, it's cyclic, absolutely. Is it planar? Sure, fine. We can talk more about planarity later, but your understanding of Vesper shapes is important here for you to be able to see that that's planar. Is the conjugation complete? Well, that's a good question. Here it matters. You have to know. You have to be able to know that these electrons can come down here and these electrons can go up here, right? By the way, can you see how these electrons are conjugated with that? It's a little easier to see when they're not on a nitrogen. These are conjugated with that. Okay? And then these electrons can go here. These electrons can go here. Forgot the formal charge. There's a plus here, a minus here. Okay, these electrons can go here. These electrons can go here. There's obviously a bunch of Lewis structures we can draw with this. Oh, that's still got a plus on it. Okay, a bunch of resonance structures we can draw with Purol. Okay, this is also on page 348 of your text. Okay? Alright, so what we've just done now is we've applied the aromaticity criteria. We've applied the aromaticity criteria to benzene and to Purol. Let's do it to one more structure and then we'll move on to the second objective. Okay? One more structure. Let's move this on to okay, this is called the cyclopentadienyl anion. Cyclopentadiene, and you can see where we're getting this name, right? Cyclopentadiene, dienyl anion. Okay, and the question is this aromatic or not? Okay, blotching again. Is this aromatic or not? And we're going to subject these to the 4 criteria. Is it cyclic? Is it planar? Is it, what was the term, the complete conjugation, the lesson calls it? Complete conjugation? And is it a Huckel number? I'm not going to answer that. I'll answer that when we get to class. Okay. And the next structure I want to show you a non-example for this complete conjugation. Watch this. Okay. So far I've drawn cyclohept, right? Because there's 7. 1, 2, 3, 4, 5, 6, 7. Cycloheptane, okay. How about cycloheptatriene? Agreed? Is it cyclic? Yes. Is it planar? Well, if we force it into a plane, sure. Again, this is a slippery one. Is it complete conjugation? Well, these are all conjugated with each other, right? But it's not here. That is sp3 hybridized. You cannot get pi electrons through that roadblock right there. So 1, yes. 2, yes. 3, no. 4, is it a Huckel number? Yes. This is not aromatic. Okay, and what I recommend you do is I recommend you go through all of these and try to think of a non-example for each of them. Okay, so that's objective 1. Let's go on to objective 2. Objective 2. Draw an orbital view of an aromatic compound. And you know what? I don't want to spend any time on that right now. I want to say go to page 348 and draw that orbital view. It's got unhybridized p orbitals in purple, sort of teardrop shapes. Okay, so at the top of page 348, that is the objective, or rather I should say that is the example for that objective. Draw an orbital view of an aromatic compound. I think the purpose there is for you to be able to see that the conjugation is complete.